Okay, we are going to go over the quick 10. Number 1 says, determine if the following equations represent direct variation. If they do, identify the constant of variation. We know direct variation is an equation in the form of y equals ax. That's just like being in the form y equals mx plus b, where b equals 0. Because we know a direct variation equation is an equation that goes through, linear equation that goes through the origin. Okay, so if we solve this equation for y and put it into slope-intercept form, if we find out that b is 0, we know it's direct variation. If b is not 0, it's not direct variation. So to solve this equation for y, I subtract 2x from both sides. I divide every term by 3, and I get y equals negative 2/3 x plus 2. Well, b does not equal 0, so this is not direct variation. And if it's not direct variation, I can't tell you what the constant of variation is, because it's not direct variation. Okay, so now, number 2, 4x equals 3y. I can rewrite that as 3y equals 4x. Divide both sides by 3. Y equals 4/3 x plus 0. So b does equal 0. So this is in the form of y equals ax. So it also means a is 4/3. So the second part of this is a equals 4/3. Okay, number 3 says, does this table represent direct variation? Well, we know if it represents direct variation, a will be constant. Now, if we know y equals ax, we divide both sides by x, we know a equals y over x. So I'm going to put all the y values over the x values and see if they're constant. Well, 5 over 3, does that equal, whoops, what did I do wrong? This is wrong because I did x over y. I'm supposed to do y over x. So does 3 over 5 equal 6 over 10? Yes, that works, but does it equal 8 over 15? And that answer is no. So this is not direct variation because there's not a constant y over x value. So let's look at number 4. We have x, we have y, we have 10 over 2, 20 over 4, 30 over 6. So I put 2 over 10 because it has to be y over x. That equals 1/5. I do y over x, so 4 over 20, and that equals 1/5. And 6 over 30, and that equals 1/5. Because each time a simplified to 1/5, this is direct variation. A equals 1/5. So my direct variation equation is y equals 1/5 x. So this is yes, and the equation is y equals 1/5 x. A common mistake is to put x over y and say y equals 5x, and that would be wrong. Okay, the next one showed a graph. It was direct variation because it was a straight line through the origin. The point was here, which is at the point 2, 3, or -2, -3. I just make that x and that y. I know a equals y over x. So a has to equal 3/2. So if a equals 3/2, my equation is y equals 3/2 x. Then it says, well, suppose x equals 4. Well, if x equals 4, I'm going to substitute that into my equation and make it 3/2 times 4. This cross simplification makes y equal 6. So when x equals 4, y equals 6, and I know that's true because if I put y over x, it simplifies to 3/2. Okay? Now, it says, given y varies directly with x. As soon as I know y varies directly with x, I say y equals ax and a equals y over x. It tells me x equals 3 when y equals 4. I say a equals 4 over 3, so y equals 4/3 x. You have to give me this equation. If you stop here, it's wrong. So that was number 7. Number 8, x equals 7, y equals 3. A equals y over x, so a equals 3 over 7, but I have to write y equals 3/7 x. Again, if you stop here, you're wrong. Okay, now number 9 and 10 are using function notation. So evaluate the function when x equals 5. And this is the function they give me. So they want me to find f of 5. That means wherever I see an x, I substitute a 5. So f of 5 equals 50 plus 4. F of 5 equals 54. Okay? Then for number 10, g of x equals negative 5x minus 1. X equals 5, so I find g of 5 equals negative 5 times 5 minus 1. G of 5 equals negative 25 minus 1. G of 5 equals negative 26. Okay, so now, if you didn't do well on this quick 10, you need to practice. There's another video and practice sheet on page 16 in this packet. You can do page 16, watch the video, and see if you got it right. Okay? There's plenty of resources in the packet for you to use and practice.